Okay, let's dive in. Looks like you want the full story on fast radio bursts?
FRBs, yeah.
FRBs, these millisecond blasts of radio waves.
Coming from way out there.
Yeah, deep space,
Yeah.
some even repeating. You've given us some really good articles and research.
There's a lot to go through.
Yeah, but let's get into it.
It is fascinating, though. It really is a complex area.
So where do we even begin with this cosmic mystery?
Well, like a good detective story, we got to start at the beginning. In 2007, this student, David Narkevich, he was going through old data
Oh, wow.
from the Parkes Observatory in Australia.
So this signal was just sitting there,
Yeah, in an archive.
waiting to be discovered.
Exactly. The signal was actually from 2001. It was so brief and strong that they thought it was a glitch.
Oh, really?
But Duncan Lorimer and his team, they saw something in it, something extraordinary. They called it the Lorimer burst. It was the first confirmed FRB.
So what made them think it wasn't just a random blip?
The way the signal stretched out across different frequencies, it's called dispersion. Happens when radio waves travel through ionized gas. The longer the journey, the more you see that dispersion.
Okay.
And the Lorimer burst had huge dispersion, greater than anything from our own galaxy. That, and it didn't match any known pulsar profiles.
Interesting.
So it probably came from far away.
So not just local radio interference, we're talking billions of light years from a whole other galaxy.
Exactly. And think about it. That burst happened when the universe was much younger.
Wow.
That's what's so valuable about these signals. It's like messages from the past
Bringing us information.
about the early universe.
That must have been mind-blowing for the astronomy community.
It was huge. But it caused some debate, too. Lots of scientists were skeptical.
Really?
Yeah, they thought it might be an instrument error or, Earth-based interference.
Right.
It took more FRBs found by other telescopes.
To prove they were real.
Exactly. Real astronomical events.
Okay, so FRBs are definitely real. But what makes them so special? What are we learning from these radio bursts?
Well, for one thing, they're unbelievably powerful.
Powerful how?
We're talking milliseconds long, but with the same energy as the sun, over several days.
Wow.
Imagine all that power in such a short time.
That's hard to imagine.
It is. And remember that dispersion measure?
Yeah.
The one that helped confirm the Lorimer burst? It tells us about the stuff between galaxies.
Oh,
that
yeah.
gas and plasma,
Yeah.
filling those vast spaces.
The stuff we can't even see.
Exactly. FRBs act like probes, so we can map that invisible matter
Wow.
by analyzing their dispersion. We're getting a glimpse of the structure of the universe.
On a grand scale.
Yes.
So they're not just flashes. They're telling us about the universe.
The fundamental building blocks.
Amazing.
And there's more. Another interesting piece, FRB 121002.
Okay.
The repeater.
The repeater.
Yeah, this one was discovered in 2012. It was the first one. Observed to burst multiple times.
So it's still out there, sending out these bursts.
Yes. And that changed everything. People thought FRBs were one-time events, maybe from an exploding star. But a repeater means a different kind of source, something that can keep going and emit those signals.
That's fascinating. So we've got these repeaters. What are the theories about the source?
Well, FRB 121102, it's also incredibly polarized with extreme Faraday rotation.
Faraday rotation. What was that again?
It happens when polarized light, like radio waves, travels through a magnetized plasma.
Okay.
The polarization plane gets twisted, and how much it twists tells us how strong the magnetic field is.
Yeah.
And for FRB 121102, it's pointing to a crazy environment.
Not just any magnetic field, but something super strong.
Way stronger than anything in our galaxy. That's where magnetars come in.
Magnetars, those super dense neutron stars.
Wow.
Those crazy magnetic fields.
Exactly. They form after supernova explosions, and their magnetic fields are insane, trillions of times stronger than Earth's.
Wow.
The conditions around a magnetar, they seem like they could make these FRBs.
But was there any proof
Yeah.
linking magnetars to FRBs?
It was a good theory. But then a big breakthrough in 2020. They found an FRB coming from our own Milky Way.
Wow. A local FRB.
Yeah.
So they could get a better look.
Absolutely. This one was called FRB 200428, and they traced it back to a magnetar called SGR 1935 plus 2000 vol 54.
So case closed then? Magnetars are the source?
Well, that's so fast. It's a big piece of the puzzle, but there's still a lot to figure out. Remember, there are all kinds of FRBs.
Right.
Some repeat, some don't. Different durations, intensities, different polarization.
So maybe different origins.
It's possible. Think of it like this. You're investigating crimes. Some might have the same culprit, others might be different suspects.
Okay, I see. So if some FRBs aren't from magnetars, what are the other theories?
One idea is merging objects, like neutron stars, or even black holes.
Black holes.
These events are super violent. They release a ton of energy.
Enough for an FRB.
Maybe.
It's hard to imagine that kind of energy.
It is, and those mergers are one-time events, so that could explain the single bursts. And then there's some wilder ideas. Some think FRBs could be from decaying particles, or even cosmic strings.
Cosmic strings?
Yeah, hypothetical defects in space-time.
That sounds pretty out there. How do they even test those theories?
It's all about data. Observing more FRBs. Looking for patterns and clues. Finding their locations is key.
Okay.
Then we can study their galaxies and look for signs of what's making them.
But you said earlier that FRBs can help us understand the whole universe.
That's right.
The dispersion measure tells us about the stuff between galaxies.
Exactly. We can use that to map the large-scale structure, that network of filaments and galaxy clusters.
The cosmic web.
Yes. It's like shining a light through fog. The light gets scattered. The thicker the fog, the more scattering. Same with FRBs. The more matter they go through, the more dispersed they get.
Oh, so we can measure that.
Yeah, and by measuring FRBs from different directions, we can make a 3D map of all that matter.
And this helps us with dark matter,
Yeah.
the stuff we can't see.
Exactly. Traditional ways of studying the universe, they only show us the bright stuff. That emits light. But dark matter is most of the mass, and it doesn't emit light.
Right.
But FRBs are sensitive to all kinds of matter.
Including dark matter.
So we can see how it's distributed and how it affects the universe.
So we've got these bursts telling us about their origins, but also revealing the hidden structure. And maybe even dark matter.
It's incredible, isn't it?
It is.
And there's still so much to learn. New telescopes like CHIME, they're finding FRBs all the time.
Wow.
More data means we can refine our theories, test our models, and hopefully answer the big questions.
This is all really fascinating. But let's go back to something. You mentioned different types of FRBs, like a zoo of FRBs. What does that mean exactly? It does sound kind of like a cosmic zoo. So what kind of strange FRBs are in there?
Well, the biggest difference, like we said, is those that repeat and those that don't. That suggests we've got at least two different things going on.
Right. And those repeaters, they seem to like those extreme environments, like around magnetars.
Exactly. But even within the repeaters, we see variations. Some of them, like FRB 180918C, show a regular pattern in their bursts.
Really?
Almost like a cosmic clock.
A repeating FRB on a schedule.
It's a real mystery. Some think it could be the magnetar rotating, or maybe interacting with something nearby. It's exciting stuff to research.
So we've got repeaters, some with their own quirks. What about the ones that only burst once?
There are some interesting ideas there, like we talked about. Maybe those are from big events, like neutron star mergers, or a star collapsing into a black hole.
A black hole?
Those would release a lot of energy, but only happen once.
So just a big flash and then nothing.
Yeah.
Makes you wonder how many we missed.
It really does. And, of course, some of those single bursts might actually be from repeaters. We just haven't seen them repeat yet.
Right, like tuning into a song. You might only hear the chorus once.
Yeah.
But the song keeps going. We just need to keep listening.
Exactly. The more we observe, the more we'll find those repeaters and understand what's happening.
Okay, so we've got repeaters, single bursters, and even those repeating ones on a schedule. What else is in this cosmic zoo?
Well, there's one that's really different. It's called FRB 191221, and it's the longest FRB ever found. It lasted 3 seconds.
3 seconds?
Yeah.
That's a lot longer than milliseconds.
Right.
What could make a signal like that?
That's what everyone's trying to figure out. And it's not just one long burst. It's a series of peaks, like a cosmic heartbeat.
You said it might be a fast-spinning neutron star.
That's one theory. But honestly, this FRB is so strange. Some think it's a brand new object, something we've never seen before.
Wow. So we're not just studying these FRBs. We might find new stuff, new objects, or even new physics.
Exactly. That's what makes this research so exciting. Every discovery brings more questions. We're pushing the limits of what we know about the universe.
This has been fascinating. Where do you think FRB research is going next?
One big question is, how do they form? Is it all magnetars? Or are there other things going on? And for the single bursts, can we find out where they came from? What caused them?
And what about the bigger picture? We talked about mapping the universe and studying dark matter.
With new telescopes and computers, we can collect so much more data. We can create better maps, learn more about dark matter, and maybe even more. Who knows what else these signals will tell us?
It's amazing how much we're learning from these radio bursts.
It is. They've gone from a weird signal to a powerful tool. For understanding the universe, there's a lot more to discover. Keep learning and see what you find.